Divisibility tests. Quick tricks or divisibility tests that we can use to determine if a number can be divided by a smaller number. So we have a few divisibility tests to go over. So 2, it can be divided by 2 when the last digit is even. Even numbers end in 0, 2, 4, 6, or 8. Now 3, it can be divided by 3 when the sum of the digits is divisible by 3. So an example would be 42. So 4 plus 2 is equal to 6. Now we can divide 6 divided by 3 is equal to 2. So this would check out. This would be able to be say that this is divisible by 3. As we added up the digits, the 4 and 2, and then divided by 3. 5, it can be divided by 5 when the last digit is a 0 or 5. And then for the numbers, 7, 11, 13, 17, 19, we're going to use long division. So let's go over a few examples. Example 1. Determine the prime numbers that 12 is divisible by. So we have 12. So first we're going to look at 2. Now, 12 is even, so it can be divided by 2. So 12 divided by 2 is equal to 6. So again, this checks out. As we also can say, and even. So that checks out. Now we have 3. Now 1 plus 2 is equal to 3, which we can divide. 3 divided by 3 is equal to 1. So that means the sum of the digits is divisible by 3, which also, we can also just go 12 divided by 3, which is equal to 4. So we know it's divisible by 3. The next number we look at is 5. Now, 12 ends in a 2, not a 0 or 5. So we would say this does not work, as does not end in a 0 or 5. The next thing we look at would be 7. Now, 12 divided by 7, not a whole number. So we would say this also does not work. So the prime numbers that 12 is divisible by is 2 and 3 from the list below. So let's go ahead and look at another example. Example 2. A new vehicle shows 2,730 miles on the odometer. Determine the prime numbers that 2,730 is divisible by. So for this, we're going to look at 2 first. And we see that 2 can go into 2,730 because 2,730 is even. So it checks out. Now 3, what we do is we add up the digits. So we add 2 plus 7 plus 3 plus 0. So we add up each one of these numbers. So we get 12. Then we go 12 divided by 3, which is equal to 4. So we can say that this is divisible by 3 as we add up all the digits, and that's divisible by 3. So that checks out. Now 5. Now 2,730 ends with the digit 0. So that then checks out as well. Now the next thing we would start doing is we're going to start doing long division. But before we do that, let's look at the other numbers. And to look at the other numbers, we're going to look at long division. And the first numbers we start to divide it by are these numbers right here. So let's take 2,730 and divide it by 2. So 2 can go into 2 one time. We get a 2 minus 2, which is 0. Carry down the 7. 2 can go into 7 3 times. So 2 times 3 is 6. Subtract, we get 1. Bring down the 3. 2 can go into 13 6 times. So 2 times 6 is 12. We subtract, we get 1. Bring down the 0. Now 2 can go into 10 5 times. And we get 2 times 5 is 10. So we subtract and get 0. So now we have 1,365. So we're actually going to then subtract and take 3 out from that number. So now 3 can go into 13 4 times. 3 times 4 is 12. Subtract, we get 1. Next, we bring down the 6. 3 can go to 16 5 times. So 3 times 5 is 15. We subtract, we get 1. Next, we bring down the 15. Now 3 can go to 15 5 times. So 3 times 5 is 15. Subtract, we get 0. So then we take this number and we're going to break it down in by the next number, which is the 5. So now 5 can go into 45 9 times. 5 times 9 is 45. Subtract, we get 0. Bring down the 5. 5 can go into 5 1 time. So 5 times 1 is 5. Subtract, we get 0. So now we have 91. So we're going to go ahead and look at to see if we can divide it by 7, because that would be the next prime number to look at. So 7 can go into 9 1 time. 7 times 1 is 7. Subtract, we get 2. Bring down the 1. Now 7 can go into 21 3 times. So 7 times 3 is 21. And we subtract and we get 0. And therefore we have 7. And then now we have 13. And 13 cannot be further divided. So we would say we are done. So the numbers that it is divisible by for the prime numbers are, so we have this 2, we have a 3, we have a 5, and then we have 7 and 13, as those are also prime numbers. So these are the prime numbers of 2,730. So let's look at another example. Now we have to determine the prime numbers of 363. So let's go over our first few numbers. So we have 2. 363 is not even because it doesn't end in an even number. So this does not work. 3 plus 6 plus 3 is equal to 12. And 12 can be divided by 3 as it equals 4. So this is divisible by 3. 5. This does not end with a 0 or 5. So this does not also work out. So let's start doing long division, as that will be the next steps to see if the other prime numbers. So 363, we can only look at this 3 because 2 and 5 did not work. So 363 divided by 3, 3 can go to 3 1 time. We get a 0. Bring down the 6. 3 can go to 6 2 times. So 3 times 2 is 6. Subtract, we get 0. Bring down the 3. Now 3 can go to 3 1 time. We subtract and we get 0. Now we have 121. And then we're going to see if it can be divided by, we'll say 7 first. 7 can go into 12. 1 time 7 times 1 is 7. And we subtract, we get 5. Bring down the 1. Now 7 can go into 51 7 times, which is 49. Subtract, we get 2. Then we're going to have a decimal. So this does not work out. Because we have a decimal, we want whole numbers. So the next number we would look at is 11. Can 11 go into 121? Now 11 can go into 12 1 time. Subtract, we get 1. Bring down the 1. Now 11 can go into 11 1 time. So we subtract, we get 0. And then we also get itself. So then we would know that we are done looking at the prime numbers. So here we have the prime numbers of 363, which is 3 and 11. And those are the prime numbers.